Okay, good evening to one Zrina. Okay, let me introduce myself. I'm Fabian Yong Chun Sing, uh, which with index number 20 TE19A 2012. Okay, today I want to present or demonstrating my practical test, which is the uh, the first practical test for communication system fundamentals. And okay, let's proceed to the practical test. Okay, in this practical test, the question asks that for us to compute modulations AM to do and find uh, the carrier frequency, which is the typical much higher than the modulating frequencies. And we've been asked also to calculate to do the calculations and find the information carrier signal generated by RF signal generator as shown in this figure ones using the oscilloscopes. Okay. And then we've been asked to construct an analog modulations system using AM simulator, and then display the full modulations AM signal with suitable modulation signal and carrier signal level. So, and compute the table with calculate that modulations index M by using formula these formulas to calculate these modulations. Okay, modulations index. Okay, that proceeds. So this is my the work that I have done. So let me demonstrate how I get this performance. So in this practical work, we have not been given the uh, digits or the numbers that we need to use in our oscilloscope setting. So we just put it by logic. And then we just open our apps. So we open the AMs and then we show it here. So let's say for our time divisions, we put it 0.5 milliseconds. So we set it for 0.5 milliseconds, and for our fourth divisions, uh, we put it set it to 5 volts. Okay, and for our carrier signal voltage and frequency, we just estimate it. We just do it by randomly. So I choose sevens for my voltage. So I choose 7 volt. And then for the frequency, I just pick the lowest number, which is 1. So I pick 1 kilohertz. And then for information signal, I choose also sevens. I just make it easy. So I just take I just pick up from this carrier signal voltage and I definitely copy it to this information signal voltage. So it's more easier to find the relations index later. And then for the frequency, I also choose 1 because it is the easiest way for us to find the waveforms and calculate the modulation index. So I choose 1, and then we connect these channels. As you can see, we have 2 channels. I'm sorry, let me explain first. As you can see, we have 2 channels, which is channels 1 and channels 2. So how do we want to connect this? We connect it, this channel 1 to the VF out. So, and then for this channel 2, we connect it to AM out. like this. So and then we generate it. So we can find, we can see how the waveform actually being shown by this AM simulator, because we have connected all of this already. So we need, and we want to see how the results is. So we just click generate. As you can see, these are the results that we have been made by using this area information signal that we've been choose early, and then we just snipping tool it and paste it in the table. So as you can see, the relations index have been given to us. So the relations index is 1. Okay, so for the calculations, we just for the carrier amplitude, we just take it from here, carrier signal, and our modulating amplitude, we take it from information signal, which is 7 volts, also included carrier signal 7 volt. And for the carrier frequency, we take it from frequency from carrier signal here, and it is 1 kilohertz. If you can see why I put here 1000 and here 1 kilohertz. For 1 kilohertz, it is the same as 1000 if you round by it. And then for modulating frequencies, also 1000, and here you can see I put it 1 kilohertz. So if you run by it, move the 0, and it will become 1000. And then how to calculate the modulation index. Okay, here uh let me show. Okay, as you can see here, we have VM and VC, which is this carrier amplitude VC, and our VM modulating amplitude. Okay, as you can see, the result and the number that we have put, the voltage that we have put in this carrier amplitude VC and modulating amplitude VM is equal, so it's the same lah. So we have choose 7 volt, and for modulating amplitude also we choose 7 volt. So how do you want to calculate the modulating index? So we just click if I'm clicking this, it's easier to show. Okay, as you can see here. Okay, our VM is 7, so we just click 7, and this slash is means divide. Yes, divide by 7. You divide it by 7, uh, and then you will get 1. So it is the same with the modulation index that we get in the waveform that we've been do in AM simulations. And then therefore the modulation index for AM for modulations for M is the same as 1. So okay, let me show you the waveforms of, since here the questions ask us to display the full modulations of AM signal with suitable modulation signal and carrier signal level. So in this waveform, we do not show the suitable modulation signal and carrier signal level. So because this is the AM simulation. So if we let me show you by using the analog mode. So in the analog mode, we can show all that figure that have been asked. Uh, okay, this may take a while because these analog modulations, yeah, we have this problem when it want to stop. Where is it? Okay. Okay. Sorry for the interruptions. Okay. Let's start it. Okay. As you can see here. Okay. We have find and we've choose the uh value of the carrier amplitude modulation amplitude, carrier frequencies, modulation frequencies in this table. So we just fill in this analog mode. So for VC is this VC is stand for this VC, which is our carrier amplitude, and our carrier amplitude is 7 volt, and we just put 7 here. And our VM is, as you can see, our VM is this, which is the uh, modulating amplitude, and it is for our modulating amplitude is 7 also, 7 volt. And FC, our FC is this, which is carrier frequency, which stand for FC. It is a 1 kilohertz, and we write it there 1000 because if we convert it, stand for 1 kilohertz. And our modulating frequency for FM is also 1000. So here FM also 1000, so which stand for yes, okay. So here we choose AM, amplitude modulating, because in these questions it asks for AM only. So we just shown the AM signal with suitable modulation signal and clear signal level, which is this three lah. Is 1, 2, 3. Okay, let's see the examples. Okay, sorry again for the interruptions. Okay, because just now my analog got problems. Okay, as you can see, this is the modulating signal, carrier signal, and modulator signal that we have get. So which is have been asked lah, has been asked here. So we just show it the examples of our signals. So for modulating signal, as you can see, it started from 0 and it go ups until I guess this is around 7 volts here. It's up 7 volt because this is 5, 6, 7, 8, 9. maybe maybe around 7 volt here, and it's go down also to sevens, up sevens, down to sevens also. And then our carrier signal also have shown the same figure, and our modulated signal. Okay, this blue line is actually stand for modulated signals, and the purple line is the envelopes. Okay, which is where our line is going lah. Okay, it's all for these analogs. Let's proceed to this. Okay, this is the example that the waveform that we get if we're using the analog. So in this particular, we only using the uh, AM simulation. So we just using the oscilloscope and so on. And after that, after we put the time divisions, spot divisions, and we choose the amplitude volt, 7 volt, modulation, amplitude also 7 volt, and we also put the frequency for 1 kilohertz and modulating frequency also 1 kilohertz. And after that, I also already shown how to calculate the modulating index, which is this VM, we divide it to with VC. So our VC is sevens, and our VM is also seven. We just divide sevens, and we will get one. So this one is our modulations index for AM full modulations. Okay, that's all from me. Thank you.